Well, hello guys, I'm Luke, full name is Luke Powell. I'm currently an e-commerce developer for Regatta Limited, which is an outdoor clothing company. Company also owns Craig Hoppers, if anybody's heard of that. I've been working there for about 4 years now. I used to work in the IT department, doing similar things to what I do now in e-commerce, which is integrating order processing, merchandising tools, marketing tools, and just generally making sure that the 18 websites and growing our functions and such like. So, loops is what I'm going to be talking about today. So, loops in Python are used to repeat the body of code several times. Now, they're exceptionally useful because loops are, I code all day, every day, and I'm always writing loops. Now, the purpose behind them is to repeat the same functionality again within the same bit of code. Now, Dan mentioned with custom nodes. Now, again, that's something that can be related to this because you can loop through custom nodes to keep all your code as concise as possible and make sure that you haven't got a load of lists and additional things that you don't actually need. Now, we're going to get onto lists now. The type of loops in this presentation that I'm going to be discussing the while loops, for loops, and recursion. So we'll start with while loops. So just to cover as well. So there's two different types of loops that these three fall under. There's a definitive loop. So this is essentially when the number of iterations or loop count is known before the program starts. So it's when we have a set bound list of items or elements, as they know in programming, and we loop through that list. So the list is never ending. It finishes, and it's known how many iterations it loops through. The indefinite loop, my apologies, is when the loop is not known how many times the loop count is unknown. So it basically means that it is possible it can be going on forever, which you wouldn't want to. It's not good for business to get stuck in an infinite loop. So in Dynamo you can use the manual mode. So use that when tinkering about with while loops because you can crash the whole program. So of course, as you all know, save as frequently as possible as well to avoid any of that happening. So while loops. So while loop is a classic indefinite loop. They're used to loop until a condition is met. So there's already a node in Dynamo that illustrates this. So in this example here, very, very basic example, it's not doing an awful amount, but it takes the number 1 as the initial count, and we essentially can use the continue while to say, okay, so keep doing something, which is in the loop body, while a certain condition is met. So in this example here, we're saying start at 1, and until that count, 1, is less than 100, keep looping. And the loop body, as you can see at the moment, is just add 10 each time. Now, if you were to output that on each iteration, it would print 1, and then 11, and then 21, etc., etc. And then the output at the end, when it finishes, when the condition is met, comes out as 101. I can show, so if I very quickly just jump to some very basic Python code. This is just straight up Python. So while loops are very useful for this kind of thing where we don't know when the loop's going to finish. So in this example here, we have number 10, that's just a variable, and we just want to print the number out until the number is, while the number is greater than 0. So in this instance here, we're just going to -1 off that number each time. So if I run that now. Cool, yeah, so we get number 10 down to 1. So that's expected. So again, you can increase this number, and we should hopefully get a list of numbers on screen, but hopefully 100 to 1. Brilliant. So, like I say, that's when we don't know how many times. I mean, we know how many times it's going to loop in this example because it's obvious. You know, we have working with very simple numbers, but in more complicated examples, we're not going to know how many times that loop will occur. So that's while loops in general. For loops are my personal favourite. They're actually very interesting to me. I don't know why, they just are. It's the definite loop, so they'll always finish. That's quite helpful. And they're used to loop through elements. So strings, characters, objects, general things like this. These are what known as elements. Or lists. Arrays are also lists, but arrays can also be nested. So you can have lists within lists within lists, which you'll have seen in the Dynamo, in some of the Dynamo notes on the previous presentation. So for loops in Dynamo then. So this again, very basic example here. We've just got a code block that defines 1 to 16. And then we feed into the Python script, which I think you're all familiar with now. And we grab that element, we call it numbers. So numbers equals in 0, just grab that element in Python. And then what we want to do in this example here is we want to find all the numbers that were divisible by 3. So as an example, this is what happens. So it loops through the numbers, so 4 numbers in numbers basically means that at each level, the variable number will be the individual elements that exist within the numbers list originally. So on the first iteration, in this example, it would be 1, next into 2, etc., etc., etc. And there's a little if statement there that basically, that's the modulus function there, so that just finds the remainder. So we just say if the number divided by 3 doesn't have a remainder, then add it to the numbers divisible by 3 array or list. And then we just output that back to Dynamo, and we get numbers 3, 6, 9, 12, and 15. So that's for loops. I got another example of some for loops in just as just written here. So again, very simple. This if statement as well, I'm going to mention this because you've been playing around with this quite a bit. So there's a function called range in Python, and that it essentially gets you a list, again a list of numbers. Now you can do all sorts of snazzy things with this. In this instance here, this is just getting me the list of numbers from 1 to 4. Now I've put here, it's very odd because you can see it's numbers 1 to 5. Now this is just the way that Python works with its indexing. Now I'm not going to go too far into it, or as this print statement should show, if I actually run this code, Python actually prefers zeros. So let me just run that through. Can't see what's happening. Yeah, so I know it's strange, but I prefer zeros. And as you can see, we've got an element as well that just has a 0 in it, so that's just a list with one element with the number 0. And that is because the range function is a bit of an odd one, so just be careful with it. I'm not going to explain why it does that. Just be cautious if you want to get a list of numbers in this example and you're using the range function, just make sure you output it to a view to make sure if you're not 100% confident with what you're doing with it, that you need to know what it is that you're going to be using as a list of numbers. So, as an example. And yes, also as well, just something similar again, another list of numbers. I've used numbers in all the examples just because it's nice and easy to illustrate that. So when we run that, you just get 6 and 8. So that if statement kicks in and says yes. So basically, we're just looping through number in numbers, and in this example, we just get numbers 6 to 8. So that's for loop. Recursion is when you call a function from within itself. So that's used in mathematics quite a lot. Now, the example I'm going to use here is in Dynamo again, and this will calculate the Fibonacci sequence. So if anybody isn't familiar with what that is, it's a term in maths, and the Fibonacci sequence is calculated by the nth value is equal to n minus 1 at n minus 2. So it's essentially the previous two numbers added together to get the final value, and then adding those previous numbers again. So this basic bit of script uses the input value from the slider, you've got to watch that to see what the number is, and what it attempts to do is, it finds the nth term of that value. So as you can see, so when you pass the number 2 in, what happens in the code is that 2 gets read, and the only line that executes, well, all lines execute, but the only one that you see happens is the out equals fib in 0. So that just says, take the number and straight away output again. But what actually happens within that fib function is that it will keep calling itself until the value has been found. So the logic for that is, again, if the term starts with 1, just return 1 because that's the one, that's the first term of the Fibonacci sequence. If it's 0, there's actually a 0, return that 0. Otherwise, return the logic for working out the Fibonacci sequence, which is again just find the 2 previous terms and add them together, and that's your current term. So this is what you use recursion for. It's to repeat the same functionality, the same body of code again, which is very similar to all the other loops. This is just a snazzy way of doing it, using recursion. So as an example of using, I've got a bit more of a kind of a slightly bloated, bloated example, but in this example we're using a for loop and recursion together to calculate a list of numbers and terms that are found within the Fibonacci sequence. So again, hopefully everything should be fine. If I can run this code, it should then output a list of so yeah, so just jumping back to the code. So again, this is just saying grab numbers 1 to 10. Again, the range function a bit tricky, so just be careful with it. And print out the Fibonacci sequence for each term. And as you can see, that just prints the first 10 numbers from the Fibonacci sequence. So loops are exceptionally useful again to repeat bodies of code and repeat functionality. This is obviously basic examples, but really they're used to ensure that the nodes that you use all the time are repeated. So you don't want, in short, you don't want to have to ever repeat the same line of code. So if you dig down at the code level, you never want to be copying and pasting. So in these terms, you will be copying and pasting nodes, but sparingly. I'd suggest if you to try otherwise to try and use the for loop. So again, using these for loops as examples. If you've got set lists and items that you want to repeat functionality on, is to use this example here to grab the list and put some logic within a for loop that will essentially allow you to filter down items. It's all about filtering really. It's about taking bigger sets of data and making some more sense out of them using for loops really. So yeah, in short, loops save me an awful lot of time. Again, I spend all my life writing loops, and I don't know where I'd be without them. They reduce complexity as well, because you don't, again, that's sort of repeat code, you don't want to repeat anything, so it succinks everything in one little place, and again it preserves readability due to that, because complexity pretty much linked with readability in these instances. So yeah, so questions?
There's a while loop as well within Dynamo.
There is a while loop set in mind, yeah. There's this example, yeah. So it's I've got to be honest. I'm not 100% knowing this, because again I've got to be honest again. I missed something right at the beginning. I'm not a Dynamo user. I'll just be very specific about that. I missed that from the beginning. So I'm not entirely sure how you use these while loops. I guess that's for you guys to kind of work out what you need to find conditions on. I really feel like the for loops from the presentation are probably what you're going to be using the most, because I think you mostly work with lists and things like that. So for loops are perfect for lists, looping through lists. But yeah, the while loops, a specific definition is to continue the body of loop until the condition is met, which my example here was showing here, where it would loop down the numbers until the condition is met. Yeah. Any more questions?
Just go back.
Yeah.
One of your, I think it might have been your forward,
This one.
that one.
Yeah.
Yeah. So there you've got for number of numbers, and then if number %3 equals 0.
Yeah.
Is percent a terminology? Because obviously you're saying divide by 3.
Yeah. Sorry. Yeah.
Is
Yes.
VBA or something like that? I'll just be using that as slash. So is percentage a...
It's specifically it's a modulus function. So in programming it calculates the remainder of the two. So you put 1 in there and you put %3, you'll get the remainder out, which is probably 2, I think. Yeah. So yeah. So it just finds the remainder, which is why you have to also have the double equals 0 as well, because you have to ensure that statement was true. It was defined by that number. So it was just a really basic example, but yeah, it illustrates the numbers. You can use that in Python to yeah. Any more questions? Cool.